Okay, so this is going to be the second part of lines, angles, and mathematical proofs. So I'm trying to gonna get this last 11 slides in on this video. So this is saying you will use GeoGebra empirically to derive a theorem based on congruent and supplementary angles. Go to this activity. So we're going to go to this activity here. And if we look here, if I move this, it kind of changes everything. So I'm just going to undo it so we're back here. So when we're talking about um, supplementary angles, it's angles that add up to equal 180. When we talk about complementary, it's equal to 90. So we're going to look at this, and it's going to say study the measurements of these angles um, and list them below. If you move the point by mistake, hit Control Z to revert back to the original setup. Okay, so that sets it up. So study the questions and list them below. If you move the point. So I'm not sure what they really want us to do here. Study the measurements, list them below. So I guess they just want us to measure this. So let's get into this. So I'm just going to list all the angles right away. That way it's a lot easier to type in. So where's my angle symbol? Angle, angle. They want us to list three angles. All right. So BAC, BAD, and BAB. And when I'm doing this, they're technically measurements of angles that we're recording. So I'm going to do M for measurement of angle, this. Usually the way I keep track of these is thinking that we're just calling it angle A. This is a different angle A, just with different endpoints, a different angle A here. So this is basically the vertex, and these right here are endpoints. So let's see what the measurement of AB or BAC is. So if I go here, BAC, that right there is going to be our 45 degrees. Go here, 45. I want to get fancy, put my little degree symbol, which is equal to CAD. So CAD, that's also 45 degrees. And the last one, where's my degree symbol? The last one here is going to be our 90-degree angle. So just post those there, and that's all you have to do for that one, it looks like. What is the relationship between AB in terms of geometric terms? So what we would do here is if we move these, let's say I move this C, if we notice these two angles are always going to be equal to each other, and our BAD would end up always being the sum. So if I do this, try to see, I was trying to see if I could get this exactly to 180. Oh, I had it. There we go. So it's always going to be these two added up to each other. So when we're writing this down, we would write something down like M equation editor. M measurement of, where's the angle symbol? Let me find my angle symbol. There's measurement of angle BAC equals the measurement of angle uh, C, which this is equal to half. Either one of these is equal to half of the measurement of angle DAB. I'm basically saying that these two angles equal each other, and both of those angles, either one of those angles, I should say, either one of those angles is equal to this. Another thing I could say is, and this is more exact, angle ABC is, oops, did not mean to do the source code, is equal to angle CAD. Oh, actually, I don't want to say that. They're not equal. I meant to say plus these two angles together equal angle DAB. I don't want to say the other thing because the angles are not the same, so we're not saying that. But I am saying this. These two angles make up this angle. And this is 100% correct, even though I'm not using the measurement, because the angles physically make it up. They physically, if you add them together, make it up. I can't say that this angle equals this angle. I can say the measurements are equal, but this angle is completely different than this angle. Again, that's just how we think of it in geometric terms. But I can't say this because they physically do make it up. So there are two things we can say about it. Select point C, we're going to move it around. Do you observe a change in the relationship? So I would say no, because I kind of did this very specifically. No, the relationships stay the same. And that's because they're still going to be equal. If I move this around, they're still equal to each other and they still physically add up to create this BAD. Question 4, we're going to move it around to make it supplementary, record what we get. So that's what I did earlier unintentionally. Let me move this over. I had it. I can do this. There we go. Perfect. All right. What do I know? So do that. Blah, blah, blah. Supplementary, record the measurements of each of the angles in this case. I wonder if we can copy and paste this. So let me see. Control C, Control V. I don't think I can edit it, unfortunately. Go into my equation. Nope. Well, it was worth a shot. So if I'm doing this, I want to say that measurement of angle. I'm just going to copy this two more times. Actually, might as well do this. Yeah, I'll just type in the letters later. And what I'm going to write here is I'm going to write BAC, measure of angle CAD. And I can even do the last angle. I guess they're not asking me for it, but I don't understand why they're not. So I guess I won't do that one. So these are both 90-degree angles. And put my little degree sign. All right. And this one. In general, what can you conclude about the pair of angles that both are congruent supplementary? So what I can basically say here is two congruent angles that are supplementary must be 90 degrees. Let me see if this works. I'm gonna just put the degrees in. Oh, it looks like it worked. Looks a little weird, but that worked out. All right. So what would we do? So this is basically a paragraph proof. We listed all of our observations. We might not have given reasons why, but we end up kind of saying everything that we wanted to say here. So again, list what you found hard, what you found easy. This one I think honestly was pretty simple. I would probably give myself a 5 on this one. And this is all that saying. If We make a straight angle. If these two angles are congruent, then that just means they have to be 90 degrees if they make a supplementary angle. So basically, if we ever have a straight line and the two angles that make it up are congruent, then those angles must be 90 degrees. So based here, if they're congruent and they make up 180, we can use the substitution property. Since those are congruent, they equal to each other by definition of congruent angles. So we can use the substitution property to show that they're equal to 180. So that's what it's talking about here. It also says we can use the transitive property, but that's essentially proofs in a nutshell. So here, they want us to write a paragraph proof saying why corresponding angles are congruent. So corresponding angles is this idea of, for example, angle 1 and angle 5. So these are known as corresponding angles. Let me kind of use my pen here for a second. Is this idea of this angle and this angle. These are corresponding angles. Also 2 and 6. So 2 and 6. The idea here is kind of like if we were to take this angle and translate it down, that's what means a corresponding angle. They correspond because we're translating it down. So we're going to write a proof on why these angles would be congruent. So the idea here, first of all, what I would say is that you guys can type it out. I'm going to kind of just write it out in this paragraph just to save on time. I would say that measurement of angle 1 plus the measurement of angle 3 equal 180 because they are, or not they are, better yet, they make a straight angle. And as we said before, you know what? I'm actually going to type this out because writing it out is taking way too long. They make a straight angle. So I'm going to say that part. And then when I get into here, I'm going to leave a space here so I can just write underneath it. I don't write straight, so I have to do two spaces. All right. And then we're also going to say that angle 3 and angle 5 also equal 180 degrees because the lines R and S are parallel. And as we learned from before, if we have two parallel lines, these two lines have to equal 180. So we've already said that before. I'm just giving you like a little reminder on that. So now we say this. Oh, then we can say therefore um, angle 5 must be equal to angle 1 because we can substitute angle 5 into the first equation. Well, that's pretty much it. We can just substitute it in and it's fine. Nothing really changes. I guess I could say that. And nothing would change. The one thing I didn't state was our given. I forgot to say that it is parallel. And you can use these for any one of these angles. So I would say like this logic works for all corresponding angles because it does. We could simply say that 2 and 4 are supplementary because they make a straight angle. These two are supplementary because they're parallel lines. They have to equal 180, otherwise these lines would cross each other. Um, from there, what we can say is that we can use substitution to replace 2 and 6, and nothing would change. It would still be true. So I would put that in. You can read their line. They talk about it way more than I do. It is. Um, I want you guys focusing on using your own words. If you're having trouble understanding why this is, again, you guys can always book an appointment with me. So let's move on. So the rest is just review on how to do two column proofs and paragraph proofs. So this was a short video. I know um, it kind of stinks I wasn't able to do this in class, but I'm going to try to like condense some time for future class videos. But again, always read your two column proofs. Always review this because it is going to come up in the mastery tests. All right, guys. So looking forward to seeing you guys on class on Tuesday.